All right, hi, my 130s. So we are continuing today with chapter 5. And this is the homework alternate assignment. This particular one I'm working through is the one that is posted on Canvas under files. Let's see. I think there was another thing for that, but I'll check later and add it if you need help with it. Okay. So for number 27, we're asked to simplify this expression. This is actually what's called a complex fraction. And the reason is there's something you can simplify on the top and there's something you can simplify on the bottom, expression wise. So let's color code this a little. I'm gonna put the top in blue and put the bottom in orange. Okay, so here's how I'm gonna do this. For the top, remember, like you can kind of, if it helps you, just cover up with your hand that whole denominator, this orange part. And then we have 1 minus 10 over 7 that we're looking at. So what you want to do, you want to find your LCD for the numerator of the complex fraction. So we have 7 for the LCD. So 1 is going to turn into 7 over 7. And you still have minus 10 over 7. Okay. And then in the next step, now we're going to look at the orange. Go ahead and cover up the blue part with your hand so that you can see just the bottom. You want to find the LCD of the fractions in the bottom of the complex fraction. So we have 6 as the LCD. 2 is going to turn into 12 over 6. And that's plus 7 over 6. So then in the next step, notice in blue, we can actually combine these fractions, right? That's going to be 7 minus 10 divided by 7. And in the denominator, we're going to have 12 plus 7 divided by 6. Okay. So now, go ahead and work on the top. We have negative 3 divided by 7. And in the denominator of the complex fraction, we have 12 plus 7 divided by 6. So that's going to be 19 divided by 6. Okay, now this is the part where I would suggest writing this as old school division. Remember, now there's nothing to simplify for the top fraction, nothing to simplify for the bottom fraction. So we can rewrite this as negative 3 divided by 7, old school divided by 19 over 6. And then that helps us because now we keep the first fraction the way it is, and we multiply by the reciprocal of the second fraction. Okay. Nothing cancels from top to bottom. Like 3 doesn't cancel with 19, 3 doesn't cancel with 7, 6 doesn't cancel with 7, 6 doesn't cancel with 19. So we're going to multiply straight across in this next step. That's going to be negative out front, 3 times 6 on the top, and then 7 times 19 down below. So that gives you negative 18 divided by 133. Okay, let me go ahead and save this picture. And then I'm going to go over we can go over number 28 next. That's fine. All right, so I'm gonna go ahead and delete this. So if you want this before I put up the recording, go ahead and take a picture. All right, clear everything. Come on, there we go. All right, number 28 is next. Again, we have a complex fraction because we have a fraction in the numerator and a fraction in the denominator of the expression. Okay, now notice no plus or minus signs between terms. In numerator, let me color code this. And give myself a little space. Okay, so here's the denominator of the complex fraction, and here is the numerator of the complex fraction. Okay, so if you don't see any plus and minus signs between, that means you can go ahead and make this into an old school division. So we have 5p to the 4th, q to the 4th, divided by 28n to the 3rd. That's going to be old school divided by 10p squared q divided by 7mn squared. Okay, so again, emphasizing no pluses, minuses between all these terms. Okay, all right, so now what we do, we're going to keep that first fraction the way it is. And we're going to multiply by the reciprocal of the second fraction. Okay, and then we can actually start canceling things when we're comfortable here, but if it helps you, you can actually rearrange and just put this all into one fraction. So multiplying straight across and putting the constants, sorry, the coefficients first, I have 5 times 7, okay, and then I have p to the 4th, q to the 4th, mn squared. On the bottom, I have 10 times 28. Then I have p squared q n cubed. Let's start with the cancellation of the numbers between 5 and 10. I have a GCF of 5. So I'm going to divide 5 by 5, that leaves me a 1. Divide 10 by 5, that leaves me a 2. Next, I'm looking at 7 and 28. The GCF is going to be 7. Divide 7 by 7, that's 1. Divide 28 by 7, that's 4. before we move on, you could actually do all your cancellation steps at once if you were comfortable, but just so it looks a little neater. Okay, so I have only a 1 left over here. So I'm going to rewrite the p to the 4th, q to the 4th, mn squared. And on the bottom, I have 2 times 4, which is going to give me 8. Then I have p squared, q, n cubed. Okay, let me go ahead and save that. If you need to take a picture, go ahead and do so. I'm going to clear out the top and then move the whole bottom up so that I can keep working. All right, let me go ahead and erase. All right, let me select, and hopefully this will move with no flaw. Okay, of course, as I'm saying that, it moves with a flaw. Okay, there we go. Let me try from here. Yes, great. Oh no, come on, fraction bar. Yay. Okay, so now what we're gonna do from here, we can stick with color coding a little bit. We have our P's. Okay, so side note, remember there's 2 ways you can think about this. P to the 4th is P multiplied 4 times. P squared is P multiplied twice, so you're going to cancel P over P. That would be P squared. Or you can say, okay, P has 4 for the exponent in the numerator. I'm going to subtract the exponent that's in the denominator, and that gives me P squared. Okay. So let me make my big fraction bar. Let me toss my 8 down here. And then I'm going to put my P squared on top where it belongs. Let's move to our next color. We're going to have Q's next. Very similar. We have Q to the 4th. That's Q times Q times Q times Q. And that's all over Q. So only 1 Q cancels. So we're left with Q to the 3rd. Or you can say I have Q with a 4 for the numerator's exponent, and then I'm going to subtract the exponent in the denominator. If I don't see 1, that means there's an invisible 1. So that still gives me Q cubed. So Q cubed will go on the top. Now the M is nice because it's all by its lonesome, nothing to cancel out, top, bottom. And then the last one that we have here is, what color? The ends. Okay, so let me erase these side notes here. This is actually a good one to show both ways. Come on, draw. So we have n times n up top. We have n times n down below, so cancel, cancel. And we have 1 over n left over. Okay, so that tells you where the n should go. Or if you say, okay, I have n and there's a 2 for the exponent in the numerator, I'm going to subtract the 3 on the bottom. That's going to give me n to the negative 1st power. Okay, when this happens, what that means, you can make n into n over 1. That's to the negative 1. If you want to get rid of the negative in the exponent, flip the 1 and the n, and then make the exponent positive. So you still come out with 1 over n. So the n should be in the denominator. Okay, and then this should be our final answer. It doesn't matter which order you put the terms in. Like I could put the m first or the q to the 3rd first. As long as they're just being multiplied by each other, you can do that. All right, let me go ahead and pause recording. All right, so we continue. We're gonna work on number 29 now. And 29 is right here. So first thing, remember, go ahead and figure out what the numerator of your complex fraction is and figure out what the denominator of your complex fraction is. Okay, so essentially here, the denominator of the complex fractions numerator is factorable. And the denominator of the complex fractions denominator is also factorable. So what you can do to avoid some common issues that pop up, go ahead and rewrite the numerator of the complex fraction completely factored. Okay, divide. And then the denominator of the complex fraction, also factor where you can. Okay, now notice there's a minus sign between the x and the -7, right? But notice that x minus 7 is contained within a factor. So there's not a plus minus between the factors 2 and x minus 7. Notice the same thing for the denominator of the complex fraction. This x minus 7 is a factor, and it's multiplied by factor 3. So what we're going to do, we can actually go ahead and do the old school division writing. I'm going to have 35x divided by 2 times x minus 7. And then I'm dividing that by 5 divided by 3 times x minus 7. Okay. Now, in the next step, we're going to keep the first fraction the same. We're going to multiply by the reciprocal of the second fraction. And then factors will cancel out. Okay. So we have a 35 that can cancel down with a 5. You're left with 1 on the bottom and 7 up top. The 3 and the 2 can't cancel. And then you need to cancel whole factors. So this x minus 7 must cancel with the entire x minus 7 from the top. So what do we have left? 7x times 3 divided by 2. Okay, note this is an x. Okay, not a multiplication sign so that you don't drop the x in the next step. We're going to have 7 times 3, that gives us 21. We still have that x right there, and then divide 2. Okay, let me save that. If you have any questions or anything, go ahead and take a picture so we can refer to this when I take another break. Okay, save. Let me go ahead and clear this out. Now for number 30, I'm actually going to start with a common misconception. Okay, Let me actually do this in red. Just, oh, shoot, nope, that's not what I wanted to do. Okay, there we go. So number 30, we'll put don't. So it's common that people say, oh, look, there's a 7x right here, and there's a 7x right here. Yes. Yep. Woohoo. Now I have 2 minus, oh, well, this would turn into a 1. That would turn into a 1. So that must be 2 minus 1 divided by 3 plus 1. Yay, that gives me 1 over 4, and I am done. Okay. Can't. Okay. You must combine the numerator of the complex fraction first, then combine the denominator of the complex fraction, then you go about old school division. Essentially the goal, you're gonna have like A divided by B divided by C divided by D. You want all of these to be factors so that you can go to the next step of A divide B times D divide C. Okay, let me save that. Take a picture if you need it. I'm gonna cancel that out. It's hurting my eyes to look at it. All right, so let's go ahead and clear that out. And then let's repeat this the way it should be done. So numerator, your complex fraction has an LCD. We have 7x in one fraction and 1 in the other. So our LCD is going to be 7x. Remember, you have 2 over 1 right now. And you're going to be multiplying that by 7x over 7x so that you get a common denominator. And over here, you already have the 7x in the denominator, so you just leave that fraction alone. Put your divide sign, and then repeat with the bottom. We have the LCD as 7x. Doesn't always need to be the same from top to bottom, so be careful. I have 3 over 1. In order to get a 7x in the denominator, I need to multiply top and bottom by 7x. And then my second fraction, the 1 over 7x, is already good. Let's simplify what we have here. Big fraction bar. We have 14x on the top divided by 7x minus 1 over 7x. And in the denominator, we have 21x divided by 7x plus 1 over x. Sorry, 1 over 7x. Okay, now we still don't have one fraction on top. We don't have one fraction on bottom, so let's combine these. We have 14x minus 1, not like terms, okay, divided by 7x, common denominator. That all is going to be divided by 21x plus 1, again, not like terms, and 7x on the bottom. Now from here, there's a shortcut you can do. If you're feeling comfortable enough with this, like with what happens in the old school division, you're going to cancel the 7x's. And then you're left with 14x minus 1 divided by 21x plus 1. Nothing factors out of the top and the bottom that can cancel out, so you would leave it. Okay, so this is kind of the shortcut. But understand why it works if you use it. The reason it works, you have 14x minus 1 divided by 7x. Old school divided by 21x plus 1 over 7x. And then from here, keep the first fraction, multiply by the reciprocal of the second fraction. And that is why the 7x's cancel. Okay, so you wind up getting the same thing out. Okay, so either way would be fine to show. Let me go ahead and save that, and then let me pause the recording so I can answer some questions. All right, so the next one we're going to talk about is number 31, and then I'm going to leave 32 for you guys to practice on your own. I'm going to get into number 33. Excuse me, and that'll be a good place to stop. We'll be done with simplifying rational expressions. In my Zoom tomorrow with my PCC group, I'll cover solving equations involving rational expressions. And then I will get into some word problems as well, and that should wrap up chapter 5. All right, so number 31, we're going to do something similar here, okay? We need to look at the numerator for the top of the complex fraction, and we need to find the LCD for it. The reason, you have the 6 over 1, right? That's a fraction added to another fraction. So LCD in this case, remember to review when your denominators have factors in them, your LCD is actually going to be y minus 1. And you might want to put parentheses around it so you remember it's a whole factor. Okay, let's go ahead and change this one first. So I'm kind of going back to the point that was brought up. Can I kind of like skip some steps if I'm already comfortable? Like this would be okay to do if you were okay with this. I know that 6 over 1, that's going to turn into 6 times y minus 1, the quantity, okay? And then this 6 is already set because it has a y minus 1 in the denominator, so I'm going to add 6. And then I put my denominator here. That's okay. All right, but just in case, I'm going to select this and move it down and show the intermediate step here. Essentially, if you're not sure, remember you have 6 over 1 from here, and you're multiplying that on the bottom by y minus 1 to get your LCD. You got to do that to the top too. Okay, then you're adding, you have your second fraction, 6 over y minus 1. It already has y minus 1 as its denominator, so you can leave it. And then the next step, just be careful here. Like this would be a distribution. So you need to leave the 6 out front and leave y minus 1. Okay. Let me move that down a little bit, sorry. So, draw. Okay, so we have 6 times quantity y minus 1 over y minus 1 plus 6 over y minus 1. And that would turn into 6 minus 1 plus 6 over y minus 1 like we have down below. Okay. For this one, so I don't have to rewrite too much here, what I'm going to do, I'm going to put numerator of complex fraction here. Okay, that's the simplification for it. And then I'm going to simplify the denominator separately, and then we'll put them together. So for the denominator, ooh, no, why? Okay, there we go. Okay, denominator in orange. All right, now we're ready. So denominator of complex fraction. We have LCD of y. So this would become 6 y minus 6 over y. Again, one more time, if you need to see those intermediate steps, we have 6 over 1 times y over y minus 6 over y. That gives you 6y over y minus 6 over y, which leads you here. Okay. Now, you see how the denominator of the complex fraction, we have 2 terms on top. We see that they can be factored, but we can wait on that. On the top, though, the numerator of the complex fraction, there's still stuff we can simplify up top. Expand using distributive property. We get 6y minus 6 plus 6 divided by y minus 1. 6's cancel. 6y over y minus 1. So I'm going to go ahead and box, or not box, but I'm going to bubble so you know it's not the right answer yet. That's just what we're going to use to replace numerator and denominator of complex fraction. I'm going to save that. If you need to, go ahead and take a picture. I'm going to delete the majority of this. So let me erase. Okay, so we have this piece here. Okay. And then we're dividing by this piece here. Cloud over cloud. Okay. So now we can actually go ahead and factor out the bottom two. So 6y divided by y minus 1, all divided by 6 times y minus 1 divided by y. And then we have our old school division. Getting all messed up with my colors here. Okay. So that's 6y over y minus 1 as a factor times y over 6 times y minus 1 as a factor. 6 cancels with 6. And you have y squared over the quantity y minus 1 squared. Be very careful here because you're going to be so tempted in this step to cancel out the y minus 1 and the y. But you really have to do that change division into multiplication first. Okay. Whoop. All right. Come on. Let's see. I can actually wait on the other one. Josh is up in terms of his time now, so I'm sorry, Josh, I've gone a little bit over. Do I have any questions before I move on? Let me go ahead and pause the recording.